Okay, one more domain and range problem. Again, let's interpret what's going on the graph. For the right, we've got that arrow, which is going right forever. On the left, or as far as the high, not left, high, we also have that arrow, but in this case, we say it's going up forever. Then over on the other side, left, we got that arrow. But as far as that left-right business goes, it's going to almost the y-axis, almost x equals 0. The y-axis has the equation x equals 0. And on the low side of the graph, again, I'm looking at that arrow, but now I'm thinking up, down, low, high. It's going down forever. So I've interpreted what my graph is doing. So domain, left to right, ex's. So on the left, we had almost x equals 0. On the right, right forever. And so I'm going to have 0 to infinity. Everybody with parentheses. And I did not do my spacing well. My range is low to high, the y's. So on the low side, it's going down forever. On the high side, up forever. Now it's going up forever very, very slowly. But it's still going to slowly go up forever. And so my range, negative infinity to infinity. And so what we really want to take away from this, domain, left to right, your x's, range, low to high, your y's. Okay, the next thing we're going to do with functions and graphs. Using graphs to find functional values, and we've seen a little bit of this already, that x's go in, y's come out. And that's all in there, and we'll just cut to the chase here. That if I want to find f of 3 from a graph, it's right there. That f of 3 equals the y-coordinate of the point whose x-coordinate is 3. That when we're talking about functional values, x's go in, y's come out. And so if I'm going to relate that to a point, your x-coordinate is coming in, your y-coordinate comes out. It's y-coordinates. Now, come homework time, you get on the computer, they put these things on nice little grids so there isn't too much guesswork. But, say you're taking a test that I actually wrote, something that looks like my notes here, not something that's on the computer, but something I actually wrote. Anytime you do something graphically, it's a good guess. Graphs are always estimates. So if I think the answer should be 2, and someone else looks at it and says, well, I think the answer is 2.1, good enough, as long as it's close. But come homework time on the computer, everything's on nice little grids, so you don't have to worry too much about it. Use the graph of f given below to find each of the following. F of negative 3. And so that's the y-coordinate of the point whose x-coordinate is negative 3. So you just go over here and you look, and it looks like that's the point right there, and so it looks like about 1. From that point, negative 3, 1. And then you just keep doing it. This is the y coordinate of the point whose x coordinate is 0. So I go and look at it, and it looks like that point right there, so -4. And that's from 0, -4. And I do it one more time, f of 2. So that's the y coordinate of the point whose x coordinate is 2. So I go and look, and it looks like that point right there, and so it looks like 0, and that's from the point to 0. Now, someone, usually when I'm teaching this to an actual classroom of people, someone will say, what if there are two answers, what do I do? There are never going to be two answers here because it's a function. And the primary thing about a function is that one x goes in, one y comes out. You are never going to get in a function an x going in and two y values coming out. For functions, one x in, one y comes out. Now these last two here, we've turned it around a little bit on you. For what value of x is y 5? And so they're just kind of flipping it around. Find the x coordinate of the point whose y coordinate is 5. And so we go up there, and it looks like it's probably a guess, but probably that point right there. And so it looks like x equal 3 from 3, 5. And the same thing on this one. What value of x, for what value of x is f of x equal -3? And this is saying find the x coordinate of the point whose y coordinate is -3. So I go and look at that, y equals -3. And let's do this in red. This shows something here. Y coordinate -3, it looks like there and there. And here we come up with x equal, and it looks like -1 and +1. And so you're saying, wait. You just said there would only be one answer. I said that about these guys up here. That when one x goes in, one y comes out. When you're given an x value, there will be a single y value. I didn't say that about y's. There can be repeated y's. If we go back to one of the very first examples in this section, if I can find it. Right here. We said that this dude was a function because there were no repeated x coordinates. And I said it really didn't matter if you had repeated y's. When you're talking about functions, you can have those y's repeat just as many times as you want. But the x's will never, you will never have an x that has two different y's. Never. You will never have an x that has two different y's. So up here, since these were all x values, x equal -3, x equal 2, x equals 0, you will never have an x that has two different y's. We didn't say that about y's. A single y can match up with, can have different x's with it. It's not the y's. It's not this that can't give you two answers. It's this. A single x goes in, a single y comes out. But it's not that way about the y's. Y's can match up with different x's. Okay. Moving on a little bit more. Equations and functions. So generally when we see functions, generally you're going to be given it in function format. It'll look something like that. But equations can sometimes be functions and sometimes they may not be. So here I have x squared plus y squared equals 25 and x plus 2y equals 6. They are equations. They're not written in function notation, but that does not mean they do not represent functions of x. Sometimes an equation represents a function of x, sometimes it does not. To determine if an equation represents a function of x, solve for y. If after solving for y, y is equal to one expression, then the equation represents a function, because if y equals only one expression, then each x value will be paired with one y value. If after solving for y equals more than one expression, then the equation did not represent a function of x, because if, for example, y equals two expressions, then each x value will be paired with two y values and thus not a function. Recall, to be a function, each x value must be paired with exactly one y value. So I have the reasons why in there. But what you have to remember is that when we are going to be asked the following questions, determine whether each relation defines y as a function of x, what you want to do is what we have up there. Solve for y. If you get one answer, one expression, it's a function. If you get more than one answer, it's not a function. So let's do this first guy. Solve for y. So that's going to be negative y equals negative 2x minus 3. Very explicitly, that's negative 1y. So I'll divide everybody by negative 1. And I get y equals 2x plus 3. I don't care what it equals. What I got here is y equals one expression. And so that tells me that what I started with represents a function. That I solved it for y, I got one expression. I don't care what the expression is, I got one answer. And because I got one answer, that meant that initially my original equation also could be viewed as a function. Because if I put x in, I get one y out, and that's the fundamental bedrock of a function. One x in, one y out. We'll finish this video and